Okay, it's that time to another lesson. This time we're going to be doing some, starting with some very simple graphics items. So without any further ado, let's get started. Okay, here we are, 1 star. Okay, that's just the name of what we're going to do. Program here, it just has 1 star going across the screen. Very simple. Okay, here were some of my notes. Going to be very simple. 1 star versus 128 stars, which we'll get to 128 in another lesson or two. But right now we just want to do one star. A lot of subjects to cover. And like the text lessons we did before, lessons 1 through 5, we're going to use BASIC to do most of the stuff for us to begin with, and then we'll move on to where we're doing it by ourselves. So let's do some review. If you aren't up to speed on the MMU and the memory layout, you need to go back through the text stuff, lessons 1 through 5, and review them. Here's what, when you turn your machine on, this is what it looks like. You've got 128 or 512K. This is the things that come in. Okay, the first 64K, as you remember, is from here at the top up here, 3F, down through 3.8, and these are the other parts that are usable. Recollect in lessons, I don't know, 4 and 5, we use this high-res text screen. Remember the 36, we moved that where we're using it up here. Okay, just trying to remember. What we're going to be using now is the high graphics screen. Okay, down here. Okay, we're going to be moving them in up in our work area. Okay, MMU registers. I know that we went through a lot of this here, but they're very, very, very important in what we do. We talked about registers FFA0 to FFA7. We only used 7 of them, but there is, we only used 8 of them, I'm sorry, but there is 16 of them. Okay, the ones we were using was FFA0 to FFA7. Now, that's known as task 0, which is the way you turn your machine on. That's what you have. Okay, we're going to be using also task 1, which is the other 8 MMU registers, which is A8 through AF. Okay, another review. Excuse me. Here's what we had. Seen this many times. This is what the machine looks like when you turn it on. Over here on the left side is our MMU registers, A0 through A7. Here's the blocks that are assigned to them, 38 through 3F, and what's in them blocks and their addresses. The same as it's always been. Now, I'll go back up once, but that is task 0 when you turn the machine on. That's task 0. All right, here's task 1. You can see everything on the left is the same. The gray ones down at the bottom, I'm down here at the normal 0 to 1 FFF is the same, but it's also going to be in MMU register A8. Also, you notice up here at where color basic is, FFAD in 3D, and the super basic is still in the same place. When you switch to task 1, what happens is these blocks are in our MMU registers, which are addressable in the lower memory, as is this block here, which means even though it says disk basic here, it's not any longer there. Right now, that's just a work area for super extended basic. Likewise down here, extended basic and anything you may have in this lower memory is not there to access. The graphics screen is in that area right now. Example, if you have how this works. Let's talk about a basic program. If you've been playing around with a basic program with some graphics, down here in the area, if you type in a basic program, we'll just say new 10 H screen 2 20 is H circle, and I know there's a whole bunch of parameters, but if that's what you want to do, how about H set? That just sets one pixel on. So we did a H screen to H set a pixel, give it an address, right? That's there. That code gets executed up here in Super Basic, and what it does is it knows what you want to do. It takes the parameters and it's going to store some of the parameters up here, up in the E0 range, and maybe some down here in the 00 range. And then it does a task 1, which immediately has the memory layout look like this, and it executes the program up here, the hput program up here, and uses the parameters from up here and down here and updates the screen wherever you had told it to do. Remember that your basic program isn't in there anymore. This is in there. So when he's done, he turns that pixel on. He does a task 0, which takes it back to look like this, back to where your basic program is. So we have the same thing. If we type in an assembler or load in an assembler language program, we can't load it in at 2,000 or 4,000 or 6,000. On our exercises, we'll get to in the future how you can do that. But now our programs, we always load them down here at E00, 1,000 somewhere's down in there. So when we load them in, we'll do a task 1, which will bring this in. We'll update this screen, and we're fine. So remember, if we put it in here at say 4,400, and we did a task 1, our program is gone. So you would be hung up immediately. Just another way to look at this. Okay, this is task 0. Here's what it looks like. And this is not to scale by any stretch of the imagination. This is what it looks like at task 0. When you say task 1, it looks like this. Okay, let's look at what we're working with here. Okay, we've got a star object. It says array. Well, we'll have an array in a few lessons later, but right now here's our object. It's only 4 bytes long. Have an address, screen address, a color of that object, and a speed. Excuse me. Example of that would have an address of hex 2850 on the screen. Color of 07, that would be palette 7, which in our example will be yellow, and a speed of 1, that's our slowest speed. If we had more stars, they'd be in an array that go on same thing, just 4 bytes for each one. Not a lot, they don't do a lot of things. What I need to explain here also is 1 byte is 2 pixels, and we're only going to be using one of those pixels in this example. Later on we'll worry about that. We're not going to worry about ANDing and ORing and masking and shifting. We're just going to say the first pixel in that byte is always going to be 00, which in our setup, our palette register 00 is black, and the screen color is black, so you'd never see a star in there. And we'll put our color here. So in this example here, we'd have 00007, we'd have 1 black pixel and 1 yellow pixel. So we're not going to be worried about doing that later on. But let's remember address, color, speed. And with that, let's look at some code. Okay, this will be pretty much like what we did before in the text screens. We'll have our common include. I'll have a new one out there for you to use. I think I only made 1 entry to it, but it does have 1 entry in it. Other than that, this part of it is all include is all the same till we get. Oh, excuse me. So we get down here. Here's where it starts for different. Okay, our screen address starts at 2,000 when we do our task 1. The screen will be at 2,000, and the end of the screen will be at 97FF. So in between there's all our many pixels that we can turn on. Come up with something new here. What we talked about before, but it's task 0 and task 1. We're going to let BASIC do that for us now. In the future, we'll get to where we can do it ourselves. Right now we're going to use basic. We're just going to get through this here. There's where the routines are located. If you got your unraveled copies of super extended color basic, you can look at them address and see exactly what they do. You'll find that out. We have one star, and that's going to be located. Our star address array is going to be located at hex 400. Hex 400 is if you're on a low resolution screen or the old normal screen, we're stored in that screen area. Okay, we use 4 bytes in there. Start our program at hex E00. We got a couple of things here, some information for a delay. We'll talk about that much later. Now we need to start looking at some code. First thing we're going to do is edit our random generator routine. Let's scroll down and find that routine's down here at the bottom. We'll take a look. Okay, here we go. Here's the init routine. And a note in here, I take no credit as I found this in a sample program elsewhere long time ago, and I've used it and it works very good. You can review the code that's here and see how random stuff works. And here's how to use it. Like if you wanted to, it will give you a number back in register D from 1 to FFFF. And if you want like a number from 1 to 15 or 0 to 15, you can AND or use AND A or AND B and use register A or B to get that. And there's another example, or you can look at it. To random, okay, I've added something to it on the Color Computer 3. In a Color Computer 3, there's a timer that's continuously running. It's at hex 112. It's from 0 to FFFF. Well, really, it's from FFFF down to 0. It's continuously decking continuously, and so it goes down to 0 and it starts back at FF. It keeps going like that, so you never know where it's going to be. So I add that to basics random, loads basics random number. I add the timer value to it, and then to make it even more random, if you're on a low resolution screen, the normal basic screen, you know, the blinking cursor, it changes color. Well, it's got a value that's continuously changing all the time. It's always changing. So I add that to that random number, store that D, and we've got a really good random seed to start with. Down here's the random code. You can look at this. It's not the easiest code to understand, but you can follow it anyway. It ends up storing our random number down here in this random word. So enough for randoms. You can look at it and check it out. So we've got our random generator initialized. Now we're going to branch to a init system like we did in the text screen. Pretty much the same exact stuff. Okay, high-speed poke, store our palette, and as we did in every one of our lessons with the text stuff, we're going to use the same palette we set up that way. Everything works together. It's common. We all know what colors we got and where they're at. We'll store them and restore them at the end of the job. We're going to load up D with zeros, and that's going to be for our foreground and background color, because the H things, for H circle, H paint, and all them things, they have a foreground and a background color, and we're going to store zeros in them too. They're side by side. You got HF color and HB color right beside it, so foreground and background together. So we'll store the use register 0 for both foreground and background colors. Then we're going to load A with 0. Okay, now some might say, wait a minute, you already got A's, already got zeros. Okay, remember this is for beginners, and just to be sure they understand what this does. If you decide you don't want to use black, you could put 07 in there, which is our yellow, and store that, and your border would be yellow. You'd have a black screen with a yellow border. So anyway, we're still going to load it back up. Yeah, I know you could save an instruction, but it's for beginners. Make sure we all understand. And then we're going to load and register B, the number 2. Okay, number 2 is what it takes to get us our 320 by 192 by 16 color screen. And we'll jump over to basic and have them do it that for us, okay? 8 screen 2, that's what we're gonna get. Future, we'll set up all of them video registers ourselves, but right now we're gonna let basic do the stuff. Let's just try to understand what all this is. Systems initialize, go back up to where we started up here. Okay, next is once you, everything we did down there, the screen is all set up to go, but it's not. Telephone rang, but it's not ready to, it's not even displayed yet. No. Once we do this jump subroutine task 1, it will be brought down in memory. Well, it will be displayed, but it won't be available to us. So if we do this task 1, it's in low memory, and most of our basic stuff is gone. So, right, place 1 star on the screen at a random location. Load X, the address of our star array, or object, and we'll branch subroutine, get a random number in between 0 and FFFF. We'll compare D to the end of the screen. If you remember up at the beginning, we had a few equates, the beginning, end of screen. The end of the screen, I believe, was 97FF. So if this come back with an address of B472, it would be too high. It would be branch high or same, random loop, go back up and try again. Until it gets a number that's lower than the end of the screen. And as soon as it does that, it compares to the beginning of the screen and make sure it's higher than that. So all it's doing is make sure it's a number in between 2000 and 97FF. Once it finds that number, it stores D and X. Remember a picture of our array, the first 2 bytes of that array was a screen address. We're going to store that screen address and bump the X register 2 bytes, which will be pointing to our speed and color. So we'll go branch subroutine, get another random return, and we'll use register B for our speed. We'll and get rid of everything other than the last 2 bits of that number's return. So we either get a 0, a 1, a 2, or a 3 for our start or our movement, our speed. Okay, and then we'll increment B by 1 to make it 1 to 4, because we don't want the 0, because 0 means don't move, and we don't want a star that doesn't move. So when we're done with these 2 instructions, we'll have a speed of 1 to 4. And the register A will mask out everything except the last 4 bytes, which will give us a number in between 0 and 15, which is, guess what? Our palette registers, okay? We've got 16 of them, and we'll have 0 through 15, and we'll store A and B. One has the color, and one has the speed into our object, and we'll be done. That's for, to look at something, let's take another look at our object, okay? Remember we had our current address, 2 bytes, 1 byte of color, 1 byte of speed. We've populated this object with that. Here's an example here. If our screen address was 2850, it would be stored in there. Our color, which in this case is 07, which in our palette, the way we have it set up, would be yellow, and our speed would be 1, which would be the slowest speed. Okay, so that's what we just did. We populated that one object. Okay, now back to our code. Okay, so we got that done. Now, next line here says remove below. Okay, this is for this lesson only. We'll override the above. Just so we can go through this with using the same numbers and be able to talk easily, we're going to take and override everything we just did up here, all this random. You can do this with your own. We're going to override it. We're going to load our star up again. We're going to load D with 2850. If you remember that previous slide, that's the number we use. We're going to use that as our screen address. We're going to store that in the array. We're going to load up A with 07, B with our 1 is our speed, and we're store D. So now our array looks like our slide does. So we'll have something that goes across the screen. We could use the random, but the address, the color we might get might be 0, which is black, and we'd never see it. We get a speed of 4, and you go hardly could see it going across the screen so fast. And if you had a black fast star, you wouldn't see it. So we're going to do this, and we can talk to it and work through it. Again, this here just explained that there's 2 pixels at each byte, so we're doing it. So now we drop down into our main loop. Okay, well, we only have star, but we're going to loop through it and move it across the screen. First thing we do is load up the address of that star again, that hex 400, and jump subroutine to move star. Let's go look at that. Okay, this here is where we're going to get back and forth some slides, and this 8 line or 9 lines, whatever it is in code here. This is the whole heart of moving this thing across the screen. That's all it takes. Okay, and one more time we're going to quickly look at our array. Address of 2850, color of 0701. That's 1 byte, 2 bytes, 3 bytes, 4 bytes. That's it. First instruction says clear. Okay, now we've got a indirect addressing. If you remember that, it's not what's in X, it's what X is pointing to. So clear whatever X is, take that address that X is pointing to. If you remember, we just looked at the slide. X, it was where it's pointing, had hex 2850 in it, which is on the screen. So clear that byte on the screen, and then update X by 2. Okay, X was pointing. What X had 400 in it, because that's where we originally said it was, where the object was. We'll bump it over 2 bytes to 402. Now we're going to load D with whatever's at X. That's what it's pointing to, whatever's in X. 402 has our color and our speed. So we're going to load D with our color and our speed and bump 2 more bytes. Okay, let's take a real quick peek again at what we did. We cleared what was at address 2850 on the screen. We bumped X by 2. It was sitting here at 28, bumped it 1, 2. So it's sitting here pointing at 07. We loaded up D with our color and our speed, and we bumped X, which is sitting here by 2. 1, 2. X now is sitting out here. Now, if we had a multiple array, we'd be sitting on 77. So X is sitting out here. Not anything to do with our array at this point. It's past our array, sitting there. Okay, so now we're past our array. We've got cleared our screen. We didn't have anything on it to begin with because we never turned it on, but we cleared it. And now we want to add to B. Well, B has our speed in it. Add to B whatever's in -3 of X. Okay, we have to flip back. So this is kind of confusing, but okay, X is sitting out here. Okay, B in it has the speed, which is 0, 1, so minus X minus 3, -1, -2, -3, which is this hex 50. So in B, we want to add 50 to what's in B, what was 1. So now in B has 51. We bumped over to the next byte over. It is sitting at register. Okay, so bear with me. We added 3 to it. Now we're going to compare what's in B to a hex 9F. Okay, one line is 320 pixels or 160 bytes. Okay, from 0 to 159, and if you look up, 9F is 159. So compare B to 9F, branch of flow, which in our case it is because we have a 51 in there, down here to store B in the -3 comma X. Okay, I'm going to go back there. Just remember, X is pointing here. We're going to go back 1, 2, 3. We're pointing at this 50 and store what's in B. What is in B? 51, because we added 50 and 1 together. Now our next byte we got, now it says 2850. I hope you're saying, oh, I'm starting to see something. I hope you are. And then we're going to, here's the next one that's kind of, you say, what are we doing now? We're storing A What's A have in it? A has our color, yellow in it, and we're going to store it, remember, indirectly. What's it? The address is an X minus 4. Okay, so let's go look at that one. A had our color in it. X is sitting here. We go minus 4, minus 1, minus 2, minus 3, minus 4. So here's our address. What's our address say? 2851, because remember we updated it. We added 1 to it and updated it. So now in 2851, we're storing, putting our color in there, and on the screen, our yellow pixel is turned on. Back to the code. Okay, we stored it there, and we're done. Okay, return back to where we come here to our jump subroutine we did here. Now we're going to do a jump subroutine over to basic. This is one of the things that still works. There are not many things work in basic with our high-res screen is in there, but this get character still does work. Okay, so if you didn't press any key, it's going to branch to a subroutine called wait. We'll talk about wait later. And we're going to do something in here, and if it's a delay is what it is, and branch back to main loop. Main loop's going to load up our star again and jump subroutine and move star. Okay, now we'll explain this one more time quickly though. We're going to clear whatever X is pointing to. If you remember, X was pointing to 2851. So we're going to clear 2851, which is our yellow pixel turned on. We're going to clear it, makes it a 0, which turns it off. And then we're going to go through the same thing again. We're going to load up our color, our speed, add B to 51. We're going to make it 52. Branch is low. We'll store it, and then we'll store our color in 2852. Return, go back up the loop and come back again. It just keeps doing that until we get here, compare it to 9. Once it gets to 9F, it'll fall through this instruction. We'll load up B with the 0, and we'll store B now. So our address now becomes 2800, which backs us way up, and we'll go forward again until we get to 9F. We'll just keep going on until somebody presses Q. Once, when they press a key, we'll compare it to a Q. If they did, we'll exit. If not, we'll go through the loop. So once you press the Q, we'll go to exit. Exits is task 0, which puts our memory blocks all back to normal. Branches to end the job, which is like we did, just like we did in the text. We'll restore the palette, slow speed poke, clear up some things, and go back to basic, and we're done. Okay, the only thing we haven't looked at is this wait loop. Okay, this is not a good way to do a wait loop when we're doing what we're doing with this graphic screen, but we're not going to get into VSync registers and stuff like that. But this works for what we're doing, but it's not a good way to when the interrupts have been turned off and you're trying to get a character. Anyway, we're going to load up our speed up earlier on. I'll scroll back up. We put in a speed of 9 and a wait time of 300. So we're going to do 9 loops of 300. And why do we do that? So I'll show you later. So then we're going to load up our speed and that wait time. And over here on the side, just if you're familiar with basic, we're going to do a for-I loop. And inside that, we're going to do a for-J loop in a sense. So we do that. We're going to put a 9 in there. We're going to do a 300 in there. We're going to go through 300 times, come down and decrement our 9 down to 8, back up, load up our 300 again and go through there. Do it 9 times, okay, and just go through and just delaying, okay. The problem when you do a loop like this and you're trying to read the keyboard, sometimes it misses the keyboard because there's no interrupt, and you just got to kind of hit it just right. So if you slow this thing down, if you was to change this speed to 20, 30, 40 loops to really get it slowing down, you may have it hit the Q key quite a few times where it actually triggered at the same time. Later on, we'll worry about VSync registers and stuff like that. Now we're just kind of keeping it as simple as we can. Need to explain one more thing, which is somewhat on the confusing side also. down here we got, which we just talked about, 320 pixels across, 160 bytes are $A0. So if we take at 2850 what we used up here and subtract the beginning of the screen, it's hex 850. That's how far into the screen we was. We take the 850 and divide it by A0, which is the length of one line. It says 0D, so we're on line 13 is where our little yellow pixel is going to be. Okay, so we take our line 13 times the length of one line is 820. 820 is the beginning of a line, not necessarily our line, but it's the beginning of a line because all the screens don't start on 00. And then if we take our 850, which is where we said is in there, minus the beginning of the line, get hex 30, or starting in column 48, pixel 48 of line 13 is where we're starting. Now, and the end of that line would be, the beginning of the line would be 820, and the end of the line would be 8C0. Okay, so I'm trying to explain this here. Okay, this top white box here is a real line on the screen. It starts at 2800, ends at 289F. We're starting here at about 2850, and we're going one time at a time till we get to 9F, which is here. Okay, when we get here, we're changing it back to 0. Okay, 0's here. You got it visually, you'll see it later. We're on two different lines here. Okay, so if I bring this in, and this here might be more confusing than it is. Here's the beginning of where we're of the real line is at 2820, and here's the end of it down to EE. Okay, we're working outside the boundaries of that line. We're saying it starts here and ends here. It really doesn't. Okay, we're going to be on two different lines here. So, oops, wrong way. So we'll run there to there, and this is the part that's the unknown. I know this is confusing, but I think when I show you a test of it, well, maybe you'll see, explain it, because I've had trouble explaining it to myself. So let's give this a try. If I can find the right button here. There goes our little dot. I don't know if you can see it or not. There goes our little dot. Okay, he's going to run through there one pixel at a time. And somewhere's in the middle of this little bright ball up here, he'll jump from one line to another line. It's very, very hard to see. Whatever that line I was talking about, when it gets down there, he jumps to a different line. So let me hit the Q to quit this. And I'm going to back up through a few commands here, if you bear with me. I know I've got it in here somewhere. Okay, I've got a test version here. Oops. Okay. So say that again. And inside that box, you'll watch him jump up a line. See, he just jumped up a line there. So, okay, one more time here. We're going to do where we had that speed and loop, instead of having a 9 in there, I'm going to put a 25 in there, which will slow it down. Maybe you can see it just a little bit, but he's going to go a lot slower through there. And inside that circle there, he's going to jump up one line. That's it. Okay, there, you got to see it that time. Anyway, you can put that's why I put that in. You can just put that in there. I wouldn't put too big a number in there. You may have to hit Q for a long time to ever get it to quit. Okay, so okay, I thought I was done, but I went back and watched what I'd done. I got to add some more to the end of this. I think if you're lost, is exactly what we did here, what we're doing. You probably need to go back into the first few lessons and come forward and understand the MMU and what really is going on there. Because it's not going to get easier, and it's not going to be magically that you're going to learn it. You need to make sure you're up to date on how to do these. I did a lot of talking and back and forth on that line when it jumped it from one line to the other line, and it might not seem very important. And with a star field of a 1 star or 128 stars, you're never going to notice it. But if you're doing something else that's graphical and you're moving things around, say a sprite or something like that, or some scenery, you need to make sure that you understand that all lines don't start on an even, 2800 address, okay? They'll start in different places. So you need to be aware of what you can do if you're moving something and you change the lower portion of the address. You may be jumping to another line. That way you'll have a problem. You'll say, oh, I remember that from way back when. Next thing we're going to do, next lesson when I get it done, will be 128 stars. We'll take and modify this code here, add to it, and we'll do 128 stars and have some fun with that. So I've got it already done. I did it a long time ago, so I'm going to show you right here exactly what it looks like. There you go, 128 stars, all different colors, moving at different speeds. Okay, so that's what it is. I'll hit my cue and end that. I will get out of this, if I may. Now, that was our demonstration. That's what we're going to do next time. Now, this might be, again, cruel or unusual punishment. I'm going to put out the common include file, because I think I added one thing to it, the RND, the random address. I think it's all I added. As far as the code, I'm going to put the code out there, the source code. But I'm going to lead out from, if you look at the screen here, I'm going to leave out from line 17. And I'll scroll down to here slow so you'll be able to stop. And when you type it in, all the way down through line 100. I'm going to leave that out of the code. I think it's your best interest to type it in and read the comments and put the comments in and understand exactly what's going on. You might in your mind, but it really helps if someone types it in. I know I've copied a lot out of magazines, and I learn a lot from that. Just by typing them in back in the old rainbow days, oh, okay, I didn't see what that is doing there. And it took the typing it in. It didn't take copying and pasting somebody else's code. It was actually typing it in. So I'm going to let you type that line 17 through 100 in. Speaking of typing things in, the parts that's on your screen right now, the move star routine, I'm going to say that's been, I guess I'd call it plagiarized. I first got this code, or not this exact code, but the same routine here way back in, I don't know if it was the Chromaset days or the Rainbow days, where somebody did a P mode 2 or P mode 3 or 4, something like that, and moved some stars around like that. And I thought that was the neatest thing going back in my early days when I first got my color computer one. I think I had an E-board was my first one. I just thought this was so, it was a little bit different than this, but I've seen this same routine half a dozen times, various ways. There's a very short routine to do it. Okay, so I won't take full credit for this. I changed it around to where it fit what we're doing here on the Color Computer 3, but I also typed it in many, many years ago. And with that, I think I am finally done. So all I can say is good luck. I hope you enjoy this, because it's going to be fun. And when we do the 128, you'll really see what we're doing. And then after that, we'll move on, and I'm not sure where, but we'll be moving on. So good luck.